Last but not least, we will calculate the variance of expected returns using the probability of different states of the world. Again, it's just the weighted average of square deviations. So instead of calculating square deviations and dividing them by n minus 1, the way we did in Business 315 and the way you did in your statistics classes, we can look at the weighted probabilities, the probabilities as weights of these states of the world. So what do? We are going to do square deviations. What is a square deviation? It's a deviation meaning expected return minus the mean return. And I'm going to log this mean return, and then I'm going to square my observation. So this is a square deviation. And now that I logged my mean return, I can simply drag my formula. So Excel will change my cell referencing for the non-locked cells, but we'll have the locked mean return. Okay, so now I have my squared deviations, and now it's part for the scaling or dividing. Instead of dividing, I can have a weighted average. My weights is my probability. So this probability times my squared deviations, and then I multiply out. Again, look at this. And the sum of this is going to be my variance. Okay, so my variance is going to be 0.035. And again, none of these are percentages. And it's 0.04, which is exactly what we got in our annual data. Now, what about our standard deviation? Our standard deviation will be square root of variance, and we are at 18.76, where the standard deviation is 20.08 here. But look at this. Our standard deviation was 18.55 for the monthly annualized data. All right, last but not least, we're going to calculate the expectations for the risk premium and standard deviation to risk premium and see and compare if they are going to be similar. So the risk premium here will be what? It is going to be my expected return minus the T-bill rate. So what is my T-bill rate? My T-bill rate will be your annual data simple average. Okay, so this is your average T-bill rate. And if you want to use geometric average, that is fine in this case, because if you remember, the smaller the dispersion or standard deviation of the sample, the smaller the difference between geometric average and arithmetic average. And here you only have 4 basis point difference. You can use this. All right, so my risk premium will be expected return minus the T-bill rate or the risk-free rate, and I'm going to log the T-bill rate because that's going to be true under any of these circumstances. My square deviation. So now my mean expected risk premium will be, and so let's insert this here, and my mean expected risk premium will be my risk premium times the probability of the state of the world. So again, this risk premium is based on the expected return if the economy is booming. And the sum of the weighted expectations is my expected risk premium given different states of the world. Now, what is the standard deviation of that? Now I'm going to take each risk premium and subtract the mean risk premium and square it. This is going to be my square deviation. I can drag it and copy paste. And now I'm going to multiply that times probabilities of each state of the world times the square deviations. And sum of those will be the variance. Okay, so now my variance will be the sum of these, and my standard deviation will be the square root, which, not surprisingly, they are They are the same. Why are these the same? They are the same because the risk-free rate that we have taken out is almost uniformly distributed. The standard deviation of the T-bill returns was about 3%, which almost gives you an almost linear reduction in the return. So the risk premium should not have had any lower or higher standard deviation than the mean returns, including the risk premium. Now, why are you doing this? Now, using this mean and standard deviation, you can again calculate the Sharpe ratio. So the Sharpe of the mean of these returns should be very similar to what we calculated before, and it is 0.45. It was 0.43 when you didn't have the smoothed or averages of expected returns. For the risk premium, we should expect something very similar. Oh, we already have the what is this? This should be the same because this is just a different way of calculating a Sharpe ratio. And what is going to be your value at risk? 5%. Your value at risk will be normal inverse. The probability is 5% or 0.05. You give it a mean, 11.74. You give it a standard deviation, and your value at risk is negative 0.12%.